Hello. What you're going to be learning about today are hypergeometric distributions. And bad news is it's a really ugly word. The good news is that it's something you've already done before. So you're not really learning anything new. It's really just going to be review of stuff we've already done before. So what we're going to do is just take a look back to what we did the day before. If we come back to look at this example where we had 6 men and 8 women, and we were forming a two-person team and there was no replacement, we drew a tree diagram and then we were able to make the probability distribution using the ands and the ors in the tree diagram. So for instance, if you wanted one man and one woman, it was man and woman or woman and man. Now, from Unit 2, you may or may not remember, anytime there is no replacement, you can actually, instead of using the tree diagram, just complete this question using NCR. So, another way you could have answered this question is in order to get one person that is a male, so the probability that the number of males is equal to 1 is there was 6 men, we're going to choose 1, and 8 women, we're going to choose 1 out of a total of 14 people, and we're going to choose 2. And when you work that out in lowest terms, that works out to 48/91. So this only works for questions that involve non-replacement. And that's what hypergeometric distributions are all about. So that's what we're going to be reviewing here. Hyperdistributions deal with dependent events, and with dependent events that means there's no replacement. And that means we're using NCR to answer the questions. So a particular challenge in Survivor has Jeff Probst selecting a team of 4 from a group of 6 males and 4 females. And we're going to determine the probability distribution where X equals the number of males. So again, everything is now in terms of males, and we're going to complete the chart. So if we want no males, so again, everything is done through NCR. So that means if there's no males, in our example, remember there is 6 males and 4 females. So that means out of the 6 males, we're going to choose none, and out of the 4 females, we're going to then choose all 4 of them out of a total of 10 people, and we're going to choose 4 of them. And this works out to 1/210. So if X is equal to 1, that means we're choosing 1 male and 3 females. So there's 6 males, we're going to choose 1, and 4 females, we're going to choose 3 out of 10 people, and we're going to choose 4. And in lowest terms, that works out to 4/35. When X is equal to 2, that means we're choosing 2 males and 2 females. So there are 6 males, we're going to choose 2 of them, and 4 females, choose 2 of them. Out of 10 people, choose 4 of them. And in lowest terms, that works out to 3/7. If X is equal to 3, we've got 3 males and 1 female. So that is 6 males choose 3, and 4 females choose 1. Out of 10 people choose 4. And in lowest terms, that works out to 8/21. Lastly, if X is equal to 4, that means you have 4 males and 0 females. So that's 6 choose 4 males and 4 choose 0 females. out of 10C4 people, and in lowest terms that works out to 1 over 14. Now, one reminder, when you do your probability distribution, you want to remember that the sum should always equal 1. So what you might want to do is add up all of these numbers and check to see that they equal 1. And if you use your fraction button on your calculator, you do find out that they equal 1. Now that doesn't guarantee that you've done it correctly because you might have made 2 mistakes that balanced each other out, but if it does not equal 1, you know for sure that you have not done something correctly. So there is a hypergeometric probability distribution. So we found the probabilities of all the possible outcomes. It's hypergeometric because it's dependent, and we are not replacing the people, because if you're forming a group, once you choose someone, you're not going to put them back, you're going to keep them. And we are using NCR throughout. Now, if you remember, to get the average number of males chosen, which is the same as the expected value, you take the first outcome and you multiply it by its probability. Then you take the second outcome and you multiply it by its probability, which is 4 over 35. Then you take the next outcome and you multiply it by its probability, which was 3 over 7. The next outcome multiplied by its probability, which was 8 over 21. And the last outcome multiplied by its probability, which was 1 over 14. And remember here that these outcomes are x, the probabilities are the frequencies, and we're dividing it by the sum of the frequencies, which is equal to 1, so you don't actually have to do that division. And this calculation works out to 2.4. So the expected number of males in the group of 4 is 2.4. And again, it's an average, so you are allowed to have a decimal. Now for hypergeometric distributions, there is a shortcut so that you don't have to do all of this work here. So the shortcut that you can take is take the group size, which is 4, and you're going to multiply it by the probability of selecting a male. And the reason why it's the probability of selecting a male is because that's what our random variable is. So the probability of selecting a male is there are 6 males out of 10 people. So we're going to multiply that by 6 over 10. So it's the group size multiplied by the probability of whatever your random variable is, which in this case x was the number of males, and that also works out to 2.4. So not all questions have a shortcut like this, but hypergeometric distributions do, so you don't have to do all of these calculations here to get the expected value. You can just do this calculation here. So here is the formula for hypergeometric distributions. Now sometimes you may have more than one group, so you might be multiplying this by C, like CX3, or DCX4, because sometimes you might have more than 2 groups. Typically there's 2 groups, but N is the population size. So in our case, that was the 10 people. R was the group size. So in our example, it was a group of 4. A is the total number of item 1. So that's usually what X is equal to. So in this case we had 6 men. B is the total number of item 2, in which case we had 4 women. And X1 and X2 will depend on how many you're trying to figure out. So if you want 0 men, then you want 4 women. If you want 1 man, then you want 3 women. If you want 2 men, then you want 2 women. So X1 and X2 are going to vary depending on which part, like how many men you want and how many women you want. And then your expected value is R is the group size, A over N is the probability of the random variable. So A was the number of men, over N was the total number of people, and R was the group size. So pause the video and you try this one on your own. And then I want you to come back to the video and check your answers. So you're going to find the complete probability distribution. X is the number of yellow marbles. So everything here is in terms of how many yellow marbles. So I want you to find the probability distribution and the expected value. Use the shortcut. And then when you're done, come back and check your answer. So press pause now, try it, and then come back and check your answer. Okay, welcome back to the video. Hopefully you tried this on your own. So there are 8 blue marbles and 4 yellow marbles. And whenever they're drawn at the same time, that means no replacement. So this is hypergeometric. So we start off with 0 yellow. So remember, X is the number of yellows. So out of the 4 yellows, choose none. 8 blues, choose 3. Out of a total of 12 marbles, choose 3. That leaves 14 out of 55. Again, 1 yellow, 2 blue. There's the answer. 2 yellow, 1 blue. 3 yellow, 0 blue. And as a check, you can see that the sum is equal to 1. And then when you go to find the expected value, it's the group size, which is 3, times the probability of whatever the random variable is. In our case, the variable is the number of yellow marbles. So there's 4 yellow marbles out of 12 in total. So the group size times the probability of a yellow marble is 1. So if you draw 3 marbles, the expected number of yellows would be equal to 1. So that is another example, just like the first one. So the last page, sometimes you're not asked to calculate the full probability distribution. You were only maybe asked to calculate one of the outcomes and not the full probability distribution. So here in example 2, 5 cards are dealt. What is the probability that 3 of the cards are face cards? So whatever we're being asked for, that's what our X is going to be. So let X equal the number of face cards. So we don't need a full probability distribution. All we're being asked for here is the probability that the number of face cards is equal to 3. So in this case, there are 12 face cards, and we're going to choose 3 of them. There are 40 cards that are non-face card, and since we're dealing 5 of them, that means that 2 of them are not face cards. Out of a total of 52 cards, we're going to choose 5. So in this formula, N is equal to 52, R is equal to 5, A is equal to 12 because there's 12 face cards, X1 is equal to 3 because we want 3 face cards, B is equal to 40 because that's the other group, which is non-face cards, and x2 is equal to 2, because if we're choosing 5 cards and 3 of them are face cards, that means 2 of them are non-face cards. And that works out to 55 out of 833. And the expected number of face cards, so that's EX. Oops, we should say the probability for communication is 55 out of 833. And if you want to round that to 3 decimal places, you can. And that would be equal to approximately 0.066. So the expected value is the group size, which is R, which is 5 cards, times the probability of a face card, which is A, because there's 12 face cards, out of N, which is 52, because there's 52 cards. So that is 12 out of 52. And that works out to approximately 1.15. So the expected number of face cards out of 5 cards is approximately 1.15. So sometimes you need to do a full distribution, sometimes you need to do just one of the outcomes, and sometimes you need to do more than one outcome but not a full distribution. So there are 6 girls and 10 boys in the playground. 4 children are chosen to help clean up the toys. What is the probability that at least 2 of them are boys? So we want things in terms of boys, so that's going to be our X. So let X equal the number of boys. So if X is boys, that means 10 is A, and the other group is girls, so that is B. And your N is the total number, which is 6 plus 10, which is 16. Now we want to know the probability of at least 2 of them are boys. So at least 2 means that your X1 could be 2, but it's at least 2. So it could also be 3, and it could also be 4. So we've got 3 possibilities. So we are looking for the probability that the number of boys is at least 2. So we've got 3 cases. So we need to look at the probability that the number of boys is 2, or the probability that the number of boys is 3, or the probability that the number of boys is equal to 4. So you really have to watch, just like any probability question, those words at least, at most, things like that. So 2 boys means out of 10 boys, we're going to choose 2, and we're choosing 4 children, remember. So that means out of the 6 girls, we're going to choose 2. Out of a total of 16 people, we're going to choose 4. For 3 boys, out of the 10 boys, we're going to choose 3, which means out of the 6 girls, we're going to choose 1. Out of a total of 16, choose 4. And lastly, 4 boys. Out of the 10 boys, we're going to choose 4. And out of the 6 girls, we're going to choose none. All over 16C4. Now, if you want to make your work a little bit easier, rather than doing these as separate fractions, what you can do is just put all of this as the numerator and just put 16C4 in the denominator. And then you can do all of this work in your calculator. So type all of the numerator into the calculator and then divide it by 16C4. If you're going to do that, you have to do one of two things. You either have to put the numerator in brackets so that it calculates all of this before it calculates the 16C4. So you have to put that into brackets. Or if you press equals before you divide by 16C4, then you don't need the brackets. So you could type all of this in, then press equals, then divide by 16C4. So it doesn't matter which way you do it, but in lowest terms, your answer should be 321 over 364, which is approximately equal to 0.882. And I guess since I've done that, what I should do is here write approximately. Oh, actually I wrote approximately here, so that's okay. So that's hypergeometric distributions. If you have any questions, then write them down and ask your teacher in the next class. Thanks. Bye-bye.